All right, for exponentials, you don't really have an issue putting this into Mathematica. You should use Mathematica as much as you can. So because that is what you're allowed to use on a graded exam. And not only that, Mathematica is something it's valued, where, using decimals is not something people put on resumes. If it's something people put on resumes, like I know how to use Mathematica, it's a good thing to know. All right, so I suggested that you always put -10 to 10. Mathematica will not plot over a real domain where it doesn't exist, and that only has an issue with the power functions with x equals with the power equals 1/3. So here I'm okay to do it, and I see something like this. And so the graph looks something like this. If you want to make your window smaller, you can go -1 to 1, so you can see a little bit zoomed in. So you see something like this. It decays down to 0. It crosses at it crosses the intercept at y equals 1, and it goes off to infinity in this direction. So this is a classic power function with base equals 4. So that's what goes here, and you have a bunch of things to choose from. It's a multiple choice question, so that's what this looks like. Now here, you're asked to what the definition is of a function with base b. I just mentioned when b was 4 that the base is 4. It's actually this second one here. It's b to the x. I really think that this question was a water sandwich. There was nothing here really to think through. What's the domain of this function with b bigger than 0? Well, let's take a look over here. Let's suppose you forget everything and you just want to. Here the domain was -infinity to infinity, but we can go back to basics. Let's say put this in here and put a few things, put 4, and here we're going to put to the x. So now it looks exactly, I'm going to put that, it says true, that means it's -infinity to infinity. Let me put 5 to the x. True. Let me put, and here they did say that the b was restricted to bigger than 0. So let me put 1 to the x and see what happens. True. So for every one of these I'm putting in, it's true. That means, looks like the domain of this function in general is -infinity to infinity. All right. If b is not 1, what is the range of this function? Well, let's take a look. What happens? Let's copy here, put that here. Big champion of copy paste. And then I'm going to take this and then put it here. And then I'm going to change this so that, 11 to the x is fine. Let's see what happens. Y bigger than 0. 2, y bigger than 0. 4, y bigger than 0. So it looks like whatever I put in as a positive value for x, as long as b is not equal to 1, it's going to be y bigger than 0. And I can see that from the graph. The y values that are covered are all in the top half of the plane. So graphically, I'm getting all y's bigger than 0. So the right answer here is all y's bigger than 0. Oh, I didn't choose a fraction. Let's choose a fraction too. Let's see. And 0 was not included. Let's just choose, for example, let's put, because they just said y is not equal to 1. They didn't say it couldn't be a half. So let's just, y bigger than 0 here too. Just to show you, the graph looks different. If I put in a half here, it goes the other way, but it also is going to be capped at y bigger than 0. And you can see that if you just plot it for, you see it's just shaped the other way. So I get something different. And just out of curiosity, what happens if y was 1, the b was 1, I get, sorry, here. If I get 1 to the x, my range is just y equals 1. And that's because if I plot y equals 1, or b equals 1, I just get a horizontal line. And so it's just y is equal to 1 because 1 to the x is 1. And so Mathematica tells me everything I need to do. How do I, the general shape? Well, that's pretty easy. I just did that over here. This is the general shape for a b bigger than 0. What's the general shape for b equals 1? Well, I just did that. I knew that back then I was going to go into math because I want to ask that extra question. So there's b equals 1. What about b between 0 and 1? I just did that too. That was the 1/2. There's it. So it goes this way. So it's so easy to do this on Mathematica. Once you have your worksheet up and running, it's pretty simple. And so my recommendation is to have these things lined up with the output on your pages of notes. You get 3 pages for the T. Put those notes down so that you know how to put this into Mathematica. Open up your worksheet and answer these questions. We're going to be making our sheets in class, and so I'm going to show you what the form is, and if you want that form, I will send it to you. So I think this is it. That's it for this time. So email me if you have any questions, or you can find me on Teams. You can text me. I'm actually good with the phone. So diana.thomas@westpoint.edu is my email. My number is 973-224-2562 if you want to text me and say, look, I really would love to have a copy of something you're doing. So just you see some of the things that I'm going to do in class with my students is have them make their page. You get 3 pages front and back, and then they're going to fill this out in class. I'm going to collect this from them so that they can't lose it. Ethan. And so here will be key shapes. Can I graph this on Mathematica so that it flags, hey, if I see a 1/3, I have to watch out for something. What do the other parameters do to the shape? What's the domain? What's the range? What can I find on Mathematica? Can I actually find the domain and range on Mathematica? So all of this will be written there. I have one for power functions. I have one for exponential functions so that we have everything laid out in a region on our sheets. So if you want this, I will send it to you.